Hello everyone, I am Dr. Krishna Sarker. Here in this session, I will be going to discuss about controllable canonical form or fast companion form. This is problem number 10, state space analysis, control system, subsets, and lecture series on state space analysis and lecture number 23. So our topics, controllable canonical form or fast companion form, state space analysis. This is problem number 10. Before this problem, please follow our previous lecture 23. What is the problem? Problem or example 10. Consider the following transfer function ys by u of s. Y of s by u of s equals to s plus 3 divided by s cube plus 9s square plus 24s plus 20. This is the transfer function ys by us, overall transfer function. And obtain the state space representation by using controllable canonical form or fast companion form. Calculate state space equation or state equations, state matrix, state diagram, and signal flow graph, and determine the stability of the systems. So our given transfer function ys by us equals to s plus 3 divided by s cube plus 9s square plus 24s plus 20. Our target state equation, calculation of state equation, state matrix, state diagram, signal flow graph, and stability of the system by using fast companion form or controllable canonical form. Solution. This is step number 1. The given transfer function is as ys by u of s equals to s plus 3 by s cube plus 9s square plus 24s plus 20. This is our given transfer function. And what is the step number 2? For this system, an auxiliary variable is introduced such that the transfer function is split as. So first step, split as ys by us equals to what? By theory, ys by us equals to zs by us into ys by zs. If zs cancel, if zs cancel, then again ys by u of s. So first split ys by us equals to zs by us into ys by zs. And this is the block diagram for this transfer function, where u of s, this is the u of s equals to reference input. And this reference input may be step, ramp, parabolic, impulse, any type of input. And this is the output for first block. And what is the transfer function? Zs by us, because Zs is the output of the first block. And second block, for second block, Zs equals to input and y of s equals to overall output. So ys by zs equals to transfer function of the second block. This is the cascade or series form actually. Then split the transfer function. Zs by us equals to what? Zs by us equals to 1 by s cube plus 9s square plus 24s plus 20. That means 1 by denominator terms. This is the first block. And for second part, ys, this is the ys by zs equals to what? S plus 3. So put here s plus 3, put here s plus 3, and in this position 1 by s cube plus 9s square plus 20, 9s square plus 20, 4s plus 20. Then case number 1, or this is the actual block diagram already discussed. us equals to reference input 1 by s cube plus 9s square plus 24s plus 20, and this is the first output z of s, and second block z of s equals to input and s plus 3 equals to gain or transfer function ys by zs equals to s plus 3, and first block zs by us equals to 1 by s cube plus 9s square plus 24s plus 20. Our development starts with the transfer function of the form zs by us equals to 1 by s cube plus 9s square plus 24s plus 20. Then solve. Step number 3. Case 1, zs by us equals to 1 by s cube plus 9s square plus 24s plus 20. Then cross multiply. Cross multiplication means zs into this term and 1 into this terms. Zs into denominator terms and us into numerator terms. Us into numerator terms. S cube into zs. This is the first term. S cube into zs. And 9s square into zs. 24s. This is the 24s into zs. 20 into z of s. And u of s into 1 or equals to u of s. Then taking inverse Laplace transform, and we get, this is the third order differential equation, s cube into zs. So put here s cube into zs equivalent to d3 zt by dt3, and 9 into s square zs equivalent to 9 into d2 zt by dt2, 24 into s into zs equals to 24 into dzt by dt, and 20s or 20 zs equivalent to 20 into zt, and in this condition all initial conditions are zeros. This is the third order system. That's why this is the third order differential equations. Then in this equation, ut equals to input. This is the reference input, and zt equals to output. But this zt not constant. Zt equals to position, and rate of change of zt equals to velocity. Again differentiate d2 zt by dt2. This is the acceleration. So zt position, differentiate velocity, velocity again differentiate, then integrate, or vice versa, integration d2 zt by dt2 integrate, then dzt by dt, and dzt by dt integrate z of t. So this is the variables terms. So put z of t equals to state variable, and then calculate state equations. So zt equals to x1 is the state variables, selection of the state variables. For this equation, z of t equals to x1. This is the z of t, and put z of t equals to x1. Differentiate both sides, and we get z dot t equals to dzt by dt equals to x1 dot equals to another state variable x2. Again differentiate both sides, and we get z double dot t equals to d2 zt by dt2 equals to x1 double dot equals to x2 dot equals to another state variable x3, and again differentiate both sides. Then z triple dot t, this is the z triple dot t, d3 zt by dt equals to x1 triple dot equals to x2 double dot equals to x3 dot. So this is our target. This is the third order differentiation, and this is the second order differentiation, and this is the first order differentiation. So for third order differentiation, this is equivalent to x3 dot, and this is equivalent to x3, and this is equivalent to x2, and z of t equivalent to x1. So put here x1, z of t equals to x1, z of t equals to x1, and we get, this is the x3 dot. Put here x3 dot. This is the x3 dot. The 9. This is the 9, and d2 zt by dt2 equals to what? x3. So put here x3. 24 into, this is equivalent to x2. So here x2, and 20 into z of t equals to x1, z of t equals to x1 and output equals to u of t. Then what is the state equation? x3 dot equals to minus 20 into x1, minus 24 into x2, minus 9 into x3 plus u of t. This is the state equation because all the differentiation terms left hand side, only differentiation terms left hand side and free of differentiation terms right hand side. This type of equation is called state equations. So this is the x3 dot. And another concept, this is the x1 dot. So first equation x1 dot and second state equation x2 dot equals to x3 and third x3 dot, sorry, this is the x3 dot equals to minus 20 into x1 minus 24 into x2 minus 9 into x3 u of t. So this is the state equation. Then what is the state equations? x1 dot equals to only x2, others coefficient 0, 0 into x1 plus 1 into x2 plus 0 into x3 plus 0 into u of t. And what is the x2 dot? x2 dot equals to 0 into x1 plus 0 into x2 plus 1 into x3 plus 0 into u of t. And x3 dot equals to already proved minus 20 into x1 minus 24 into x2 minus 9 into x3 plus 1 into u of t. So these are all state equation, and from state equation determine or calculate state matrix. So next step number 6, the state matrix. x1 dot, this is x1 dot, x2 dot, x3 dot, left hand side x1 dot, x2 dot, x3 dot, and first coefficient 0, so this is 0, 1, 1, this coefficient x3 coefficient 0, this is a 0, 1, 0, and another coefficient second row 0, 0, 1, this is 0, 0, 1, and minus 20, minus 24, minus 9, this is the minus 20, this is minus 24, minus 9, and ut coefficient 0, 0, 1, so 0, 0, 1. So this is the state equation x dot equals 2. So this is the x dot, this is actually x dot, and this is a, and this is x plus b, this is b u. So this is the state diagram, state equation, state matrix, and from state matrix this is equivalent to x dot equals to x plus bu, and this is a special structure of the matrix. Only last row negative coefficient and super diagonal elements 1s and others coefficient 0. This type of matrix is called companion matrix or companion form or first companion of the matrix. So next steps, step number 7, case 2. What is the ys by zs? Second part. This is multiplication, cross multiplication, s into ys, sorry, ys into s, zs into s plus 3 into zs, and left hand side y of s, and taking inverse Laplace transform, and we get ys equivalent to y of t, s into zs equals to dzt by dt, and 3 into z of t. This is the state output equation. Then put z of t equals to x1 state variable, z of t equals to x1 state variable. This is already selected, state variable x1, and dzt by dt equals to z dot t equals to x1 dot equals to x2. So this is equivalent to x2, and this is equivalent to x1. Put and determine the output overall equation. So what is the output equation? Yt equals to, this is the x2, this is 3 into x1. That means yt equals to 3x1 plus x2, 3x1 plus x2. The output y of t equals to 3x1 plus x2, and x3 coefficient 0. That's why 3, 1, 0. x1, x2, xt, because 3 into x1 plus 1 into x2 and 0 into x3. This is the equivalent to y equals to cx and D matrix equals to 0. So C matrix equals to 3, 1, 0, 3, 1, 0. The state diagram. Draw the state diagram. What is the state equations? x1 dot, x2 dot, x3 dot, from and output equation yt equals to 3x1 plus x2, and this is the state diagram. This is the state diagram. First, this is x3 dot. This is x3 dot. x3 dot integrate, then x2 dot. This is the x2 dot. x3 dot integrate, then this is the x3 dot. Integrate x2 dot. x2 dot equals to what? x2 dot equals to x3. Again x2 dot integrate, this is x1 dot, and x1 dot equals to what? x2. x1 dot integrate, this is x1, and x1 equals to what? This is equivalent to z dot t. This is equivalent to z dot t. So first integrate and then feedback path. So first x3 dot, this is the x3 dot. x3 dot equals to what? Minus 20 into x1. So this is the x1 terms, and this is the x1, and this is the 20. So this path minus 20 into x1, minus 20 into x1. So x3 dot equals to minus 20 into x1, and second part minus 24 into x2. So this is the x2 multiplying by 24, and this is the 24 x1 minus. So add x3 dot equals to minus 20 into x1 minus 24 into x2, and another path minus 9 into x3. This is the x3 path, this is the x3. So multiply 9 coefficient, and this is the 9 into x3 minus. So the final equation x3 dot equals to minus 20 into x1 minus 24 into x2 minus 9 into x3 and plus u of t. This is the u of t because this is the comparator. This is the comparator. So x3 dot equals to satisfied this equation. Satisfied this equation. Then what is the output? Output equals to 3 into x1. This is the x1 multiplying by 3. So this is 3 into x1 and another 1 into x2. So this is the x2 path. So 1 into x2. So yt equals to what? 3 into x1 plus 1 into x2. This is the overall state diagram for given transfer function by using first companion form or controllable canonical form. This is the overall block state diagram. And what is the signal flow graph? What is the signal flow? Block diagram to signal flow graph. So this is the input u of t. So draw first input u of t, and this is the output y of t. This is the output y of t, and this is the this part 3. So put this is 3. So this is 3, and what is the feedback path? This is x1 into 20, x1 into 20, x1 into 20 minus x1 into 20 minus x3 dot equals to. So this is the minus 20 path, and this is the minus 24 path. This is the minus 24 path. This is minus 9 path. This is minus 99 path. So x3 dot in this position, x3 dot, x3 dot. So x3 dot equals to what? Minus 20 into minus 20 into this is the x3 dot. x3 dot equals to minus 20 into minus 20 into x3 minus 20 into x1 minus 24 into x2 minus 9 into x of 3 minus x of 3, and y of t equals to 3 into y of t equals to 3 into x1 plus 1 into x2. This is the y of t. So this is the signal flow graph for given problem. What is the conclusion? If the direct path through beta 0 or b0 is absent, the reference figure, then the scalar d is 0. So in this problem D equals to 0. That means this is null matrix and the row matrix C contains only the beta coefficient, and the matrix A has the very special structure. The coefficients of the denominator of the transfer function lead by minus sign from a string along the bottom row of the matrix. The rest of the matrix is 0 except the super diagonal terms, which are all unity. In matrix theory, a matrix with this structure is said to be the companion form. For this reason, we identify the realization as companion form, realization of the transfer function. We call this is the first companion form or controllable canonical form. Thank you.